related rates in algebra and geometry. The question is, a spherical balloon is being inflated at a rate of 420 inches cubed per second. At what rate is the radius changing when the radius is equal to 20? So the question gives us dV, which is the derivative of the volume formula, is 420 inches cubed per second. It also gives us the radius, which is 20 inches. It only gives us the radius at that given time. And we want to find dr dt to find out how fast the radius is changing. We know the volume formula for a sphere is V equals 4/3 pi r cubed. So what we need to do is go ahead and take the derivative to be able to solve this problem, so we can work with dv dt and dr dt. So we know if we take the derivative of dv turns into dv over dt. 4/3 turns into 4 pi r squared dr dt. Now the easiest part comes in. Now we can just plug in the numbers that we know. So we know dv dt is 420 is equal to 4 pi, and we know r is 20 squared dr dt. The goal is to get dr dt by itself because that's what we want to find. So first we go ahead and we just simplify. So 20 squared is 400, and we get 420 equals 4 pi times 400 dr dt. We end up with 1,600 pi dr dt is equal to 420. Now what we need to do is divide the 1,600 pi to the other side. The answer leaves us with dr dt is equal to 0.084, don't forget the units, inches per second. Part B is, if the balloon is inflated at a constant rate, does the radius also increase at a constant rate? Why or why not? So we know that the increase of the radius is this number here. If we plug any number in, there is no place to plug a number in. So every number that we could possibly plug in would always be 0.084, which lets us know that the rate is constant and the radius will always increase at 0.084.